So, in our previous class, which we had in December, we would have wrapped up this chapter here, chapter 9.3. So if you would have missed that chapter, please ensure you watch that class. That would have been this one here. Roughly 2 hours to finish off that chapter there. So all the information in this chapter, chapter 9.3, is very important for your exam, because CXC tests you a lot on programming. So it's very important you get an understanding of programming. So we would have covered how to create a pseudocode, how to do input, how to do output, how to carry out your processing. We looked at what is a sequential statement. We looked at what are conditional branching, the if then, and the if then else. Those are the two conditional branching. And then we looked at nested condition, which is basically putting one if statement inside of another, similar to how you would have done in spreadsheet, where you place one if function inside of another. And we learned about the 3 types of loop statements: the while loop, the repeat loop. There are 4 key differences that you need to remember, because that could be a question in your exam. And then the final loop is the for loop and how that worked. So all of that we covered in that class there. So any questions before we start the new chapter? Alright, so let's continue. So when we had started chapter 9.2, was it? Yes, chapter 9.2, when we were looking at algorithm design, we basically said in the first chapter, the first paragraph, that there are 2 methods to create an algorithm. There is pseudocode, and then there is flowchart. And as you would have seen as we went through that chapter, a pseudocode uses English type statements, or basically English words, various statements and keywords for creating that pseudocode. Today we are going to be focusing on flowchart. And what does flowchart use? It uses diagrams. So notice here in this table, we'll be learning about all the various diagrams that make up a flowchart, what each symbol represents, how they play the part. So this here is an example of what a flowchart looks like. Here are a few more examples of what we'll be going through. And basically, the same thing you would have learned in chapter 9.3 about conditional statements, the if then and the if then else, we'll be learning how we can create those same statements in the flowchart. So even the nested conditions, we'll be learning how to incorporate that into the flowchart. So basically all the statements we learned in pseudocode, the loops also, the while and the repeat, we'll be learning how to construct those in our flowchart. So that's what we'll be covering today. So let's look at our first paragraph. So the first paragraph states that flowcharts are algorithms, and remember, an algorithm is basically a series of precise steps that will lead to a solution. So a flowchart is just another method of creating an algorithm. Now, that uses symbols to depict the input, the processing, and output of data and information. So these symbols use the same terms to illustrate the flow of data as the statements in pseudocode. So the same keywords that you would have learned in pseudocode, the input and read keyword, which indicates that you are putting data into the program. We have a symbol here, notice, that indicates we are putting data into the program. So this symbol here is basically the same as using the keyword input and read. Also for processing, notice we have a symbol here for process. Whenever we have a calculation, we can put that calculation in here. And once again, for output, those keywords, output, display, print, write, and so on, we have keywords, we have a symbol, the same symbol here, the parallelogram, that represents that action there basically. So for your exam, it's very important for you to remember what each symbol looks like. You have to remember what each symbol represents, what is their name, and what they are basically used for. So let's look at the first symbol. The first symbol is basically an oval, not a circle. Please note that we have a circle symbol. So our first symbol is basically an oval, not a circle. So that symbol is called a terminator. What is this terminator used for? It's used for identifying the start and the end of our flowchart. So let's compare that to our pseudocode, which you would have covered. When we were creating a pseudocode, we would have learned that the title indicates the starting of our pseudocode, having a title. Now, what indicates the end of our pseudocode? Well, the keyword end. That indicates the ending. So, a title for our pseudocode indicates a start, and the keyword end indicates the ending of our pseudocode. So, if we relate that to our flowchart, the oval terminal represents the starting and the ending. So if you look at an example, look at this example here. Notice the oval is here and it has the keyword start inside of it. And at the bottom here, we have another oval ending that flowchart, and it has the keyword stop inside of it. So this is once again is called the terminator symbol, and it's used to indicate where you are starting and where you are ending in your pseudocode. In your flowchart. Are you guys following so far? Great. If you have any questions at any point in time, feel free to stop me and ask your questions. Good afternoon. So, our next symbol is the parallelogram, which is basically used for input and output. So whenever you want to put data into the program, whenever you want to take data out of the program, we represent that using the parallelogram symbol or the parallelogram shape. So as I mentioned, to accept or to output. So let's look at an example of that. Notice here in this example, remember parallelogram is for input and output. Whenever you see I/O, let me try to write that a bit better, I/O, that is usually an indication of input output. It's a shortened form of input output. So here the parallelogram at line number 1, or the first shape here into the flowchart, we have an input keyword indicating we are putting data into the variable called number 1. You're putting data into the variable called number 2, and you're putting data into the variable called number 3. So here we are using the parallelogram to indicate we are inputting data. Now at the next symbol, the third one here, we have the output keyword, which is being used once again for input output, and in this case we are outputting the result of the addition that we carried out here. So once again, the parallelogram symbol or shape is used to indicate we are either putting data or inputting, or we are getting data out of the program, or basically output. Our third symbol, the rectangle. The rectangle is used for our process, and whenever you hear the word process, always think of the word calculation. That's basically what we mean when we say process. Process means we are calculating something. So when we are doing arithmetic calculation, when we are adding something, when we're subtracting, multiplying, division, whatever the case may be, all of that falls inside of the process symbol when we're carrying out calculation. So let's look at the second symbol here. So notice here we have a process. This is the process symbol, a rectangle, and inside of it we have a calculation. We are calculating, we're adding the variable number 1 plus the variable number 2 plus the variable number 3. So we're adding these 3 variables here together. Thus we are having a calculation inside of the process symbol. So 3 symbols we covered so far. Our fourth symbol, the diamond. The diamond is the decision symbol. Now the decision symbol is used for conditional statements. And if you can remember, conditional statements are our if then and if then else statements. Those are our conditional statements. Conditional branching, conditional statements, basically the same thing. So if then else, those are our 2 conditional statements. So the decision symbol, also called a conditional statement, it's used to ask a question, to determine the next step or option, one line in but more than one line out. We'll come back to that last part later down into the chapter. But just note that decision symbol is a diamond, and that is the conditional statement. That's the if statement. So look at an example here. Here we have a decision. And remember, whenever we have a decision, that means it's a condition. And I always say, whenever we have a condition, think of a question. Always ask it in a question format. Whenever you come across a condition, ask it in a question format. That's why they have the word is here. So you're basically asking, is Mark greater than or equal to 80? Decisions are always basically a question. So you ask it in a question format. Is mark greater than equal to 80? And the answer to that question, remember, it's always going to be one of two answers. Either it is going to be true or it is going to be false. There's nothing in between. It's either the answer is true or the answer is false. Even if you say I don't know is a false answer because it is not correct. So whatever a person say, even if they do not say anything, even if they do not answer, it's still a false answer. So it's either true or it is going to be false, whatever a person may answer to that question. So in this decision here that we're carrying out, in this question, the no is an indication of false and the yes is an indication of true. So is mark greater than 80? Then we simply head in the true direction if it is, and if it is false, we head in the no direction. And that's how we get that's how we take different paths in our flow chart depending on the condition of our question. You guys clear enough?
Yes, sir.
All right. So our fifth symbol, the connector symbol. Now notice this symbol is a circle in contrast to our oval once again. The connector symbol, a link to a external element or detail not included in the visible flowchart. So basically, in a nutshell, it is used as a link. It is used to connect, hence the word connector. So it's used to connect something. What is it connecting? It's basically connecting one part of a flowchart with another part of a flowchart. So what do we mean by that? Say for instance this document here. If you notice, all the information cannot fit on a single page. Notice when you start typing too much information, it flows over into the next page. And if I start typing more information, it will go over in the third page and it will continue like that. So in cases like that, what you can do, say for instance, give me a second, I just realized, I just remembered that I can draw in Word, but I just need a blank document. Yeah. So say for instance, you're creating a flowchart. Now remember, when you're creating a flowchart, you have to start with an oval and you put in the keyword start. And you draw your line, you put in your rest of shapes, and you continue. Now remember, you must draw another oval and indicate stop. So this here is a flowchart, and we have a starting point and we have an ending point. That is very important. Now, say for instance we have a very lengthy am I not allowed to? Say for instance we have a very lengthy why is this works like that? Come over here. Good. Say for instance now we have a very lengthy pseudocode. So in this case here we're gonna start and we keep going down and we draw our symbol, we keep going down draw another symbol. We're going down again. Another symbol. Another symbol. But notice we reach the end of the page. What am I supposed to do? I can't put the terminator and say I'm stopping here because I don't want to stop here. So one example of what you can do is to indicate that you are basically putting a terminator symbol, a connector symbol here, so that when you go over to the next page, why am I still drawing? Yeah, so that when you go over to the next page, you can continue with that. So you can continue with the connector symbol and indicate that you are continuing like that. So it can help you indicate that you did not stop at that page, that you're continuing onto the next page. That is one method of using the connector symbol to indicate that you're going, when you have different pages, everything can't fit on one, indicating that you're connecting one between the other. Now there's another way whereby you can use the connector symbol. You guys clear on this one here before I move on? Clear on the first one?
Sir, could you just go it over a bit?
Alright, so the connector symbol, as the name implies, it is basically used to connect. What are we connecting? We're basically connecting one flowchart to another. So with this example here, the one in the left hand, it's a very small flowchart. We have start, then we have another symbol in the center, and then we have stop. This is the basic layout of a flowchart. It must have a starting point, it must have an ending point. Now the one in the right hand, we have a start, and we're going through with various symbols, but eventually we reach the end of the page. Now we have to go over to the other page, right? So instead of putting a stop here, because we have no more space, we can indicate with a connector that we are going over to the other page, basically indicating that this part of the flowchart is connected to this part here of the flowchart. So these two are connected. That's basically what we're doing here, indicating that the two are connecting to each other. Did that help?
Yes, sir. So even though it's on two different pages, you need to put the connector at the end of the page and at the beginning of the next page, and not just use one.
You actually you can continue it. Like for instance, if you put a symbol here, you can put an arrow, and then you can continue with the other symbol like that. You can actually do this here if you want, or you can do it with the method over here. I'm just showing you how the connector can be used. It's not like a mandatory something.
Okay, thank you.
So the main purpose of the connector, once again, is to indicate that one part of the pseudocode is connected to another part of a pseudocode. That's the main purpose. So the other example is this one here. So say we have start here, and we have a symbol here, and we have another symbol, and then here we have a connector symbol, and then here we have another connector symbol. So nothing is in between here. So it goes from here to here, and then from this connector it goes to another symbol, then another symbol, and then we stop here. So notice we have two connector symbols here. One, let me not do that. Yeah. So you have two connector symbols there. So outside on the right hand now, I could have one there, one connector symbol there, come down, and I could write in this section here a series of actions in this flowchart. So I can put a series of actions here and then end with another connector. So basically what is happening here, what I'm doing here, the one on the left hand side, the one in the left, so flowchart number 1, flowchart number 2. So number 1 is my main flowchart. I'm going from starting to ending. So remember, we always go from starting to ending, start to stop. But if you notice in the center, we have two connectors here. And remember, connector is used to indicate we are connecting one flowchart to the other. So this example here, what we can do, we are basically indicating that when we reach, we're coming down here basically, and when we reach to this connector, we jump over to this flowchart over here. So then we come down this flowchart here, and we reach this connector here, and we come back over here. It's kind of like we're following the dots, kind of like that. And then we come down to the ending here. Remember, our program, flowchart, pseudocode, whatever we're looking at, all works sequentially. So that means it goes in a logical order, one after each other. So if you notice, when we're actually going in a line, it might not be a straight line, but if you can imagine it, if you were to straighten this line, it would actually be a straight line. So if you notice, it's going in a logical manner, one after each other. So this is how the connectors work, that we can connect one point of a flowchart to another and basically use it in that manner. So these are the two uses. One, whereby we can build a whole flowchart separate and basically kind of like plugging it into the main one. Or we can simply use it to indicate you are going from one page to the next. But like I said, that's not mandatory. You could always do it this way. Simply go from one symbol to the other. You guys clear on that?
Yes, sir.
Yes, sir.
Anyone with any questions?
Sir, I have a question.
Go ahead.
So, like, instead of using the connector pin to connect a flowchart, like in this instance, can we use the processing diagram to connect it from another page to another page? Like, continue on to this page or something like that?
Yeah, you could. I didn't fully understand the question, but like in this case here, you use a diamond like this here and then go over to the next page.
Yeah.
Yeah, that can work also. Once the lines are like clear enough to indicate that it goes from one part to the other, I would assume that's good enough. Once these are called flow lines. That's going to be a next symbol. These are called flow lines, and they indicate where the data is going, what's the direction. So once you can clearly indicate that that's the direction of the data, that should be fine. But this here, this is when we were covering chapter 9.2, we were learning about subroutines. And if you guys can remember, subroutines, it basically means you can take a large program. So this is a program. You take a large program and you break it up into chunks. You break it up into procedures. You break it up into modules, different parts. So this is part 1, part 2, part 3, and so on. And what you can do, you can say different persons can handle different parts of it. So Akhilesh can take this part, Deringer can take that part, Lee can take that part, and you can work on that part of the program. Similarly, a person can do that with their flowchart. They can say, look, Akhilesh, you can take the first part of the flowchart, you work on that. The ranger can take this second part, and Lee can take this third part. So each of you individually work on your own part, and by indicating with with connectors, we can tell that which part is connected to what part of the flowchart, which part is connected to what, so that we can make one large flowchart. That's also why we do it this way also. So in this case here, like, let me draw another one. In this case here, let me give you a more practical example of what could happen. So you start here, and then you have a symbol, whatever the case may be. Now here you might have a diamond, which is basically a decision, right? And we just learned a decision takes different paths. So like in this case here, we can say when you come out here, go to this connector here, and then this part here is going to continue here like this here. That, and where, let me see, where we might we put the I guess we can draw a line like this here. Yeah, we could draw a line something like this and put another connector there, another symbol here, and then we stop here. So in this example here, over here now could have a connector and some sort of action, something else going on there, and then another connector here. So what's going to happen here now, we're coming down, and say we go this way, we go straight down. This is one way of traversing this flowchart. But the other way could be we're coming down from a start here, we reach the decision, and the decision comes out on the right hand side here, so we go over to this part of the flowchart, the other flowchart with that connector, we come down and we reach the other connector, and we come over back here. So we join in back into the main, and then we come down back here. So this is a more practical method of using that connector there. Think you guys follow that? Or is it difficult to understand? Are you guys following, or is it difficult?
Sure, I'm following.
Yeah, I'm following.
And what about the rest? The rest of you following?
Yes, sir.
Alright. So once again, connector is basically, as the name implies, to connect. What you're doing, you're just connecting one flowchart to another flowchart. It's that simple. It's like connecting the dots. So the final symbol is your flow line. So it's basically a line with an arrow. Now these lines with arrowheads determine the flow of data from one symbol to the other. So you're going to see them in all the examples. You're going to see a line with an arrowhead indicating where the data is basically flowing, top to bottom in this case here. You can notice all of them. The line is going downwards, and you see that arrow there. Because of the arrow, you notice it's going down. So these are our 6 symbols. that you need to remember that what each one does. The terminator, once again, indicates start or stop. Parallelogram is for input and output. Rectangle is a process, which is basically calculation. Diamond is for decision, which is your if statements. The circle is for the connector, and the arrow is for your flow lines. Any questions so far?
No, sir.
Alright, let's move on to the next paragraph. So, each symbol represents an action or condition. Now, let's compare that to pseudocode. What we would have learned in pseudocode, we would have learned that pseudocode is made up of statements and keyword. And what is a statement? A statement is an indication of an action or condition. So, the equivalent of a statement is basically a symbol. In pseudocode, a statement or keyword indicates what is happening. In flowchart, a symbol indicates what is happening. Now, within most symbols, text is used to describe what is happening to the data, while the arrows indicate the flow of data from one symbol to the next. So we already covered that if you notice, in most of the symbols, basically in all the symbols, even though we know that the symbol represents start and stop, we still have that keyword inside of it. Even though we know that the first and the second symbol indicating input and output, it still has that keyword inside of it. Because think about it, especially for this parallelogram. The parallelogram is used for both input and output. So say for instance we did not have this input keyword here, and we did not have this output keyword here. So what would have happened is that we would have seen the variable number 1, 2, and 3. We would have seen result of addition, but we won't know whether we have to input or whether we have to output. So in these cases, that's why it's important to have the keyword also, so that we know we have to input at this first step here, and we have to output at this step here. So next we're going to look at some rules that you must follow when you are creating your flowchart. So our first rule, every flowchart must have a start symbol and a stop symbol. So we already know what that is, that oval. So that's what I've been saying when you were covering the connectors, that you must have that start symbol, you must have that stop symbol. Just like in flowchart just like in your pseudocode once again. In your pseudocode, you must have a title and you must have the keyword end. Similarly, you must have that start and stop symbol. Unless you are drawing a section of a flowchart. So that's this example here. So notice the one in the right hand, this is a section of a flowchart. So notice it does not have a start symbol, it does not have a stop symbol, but the connector symbol is indicating that it is a part of a much bigger flowchart, or it's a part of a flowchart that has the stop and the start. So it does not need to have that here. So this is the only exception. So whenever you're creating a flowchart, it must have start and stop. But if you're creating a section of the flowchart using the connectors, it does not need to have that start and stop symbol. The last part, the start and stop symbols are called terminals or terminator. Our second rule, the use of arrowheads on flow lines where the direction of flow may not be obvious. So basically, use arrowheads on your flow lines. Now, if you actually read it carefully, use arrowheads on flow lines where the direction of flow may not be obvious. It's kind of indicating that it's actually not necessary to draw that arrowhead. Because if you think about it, let's look at this example here. Now, even if these symbols here, why did it go so high? Even if these symbols here did not have an arrowhead, like this here, it's actually obvious what direction it's going in, because we're seeing that keyword start, and obviously we have to start at the word start, and then we go downwards and we stop at the word stop. So it's obvious that we're going downwards. So even if you draw bare lines with no arrows, it's an indication as to where we have to go. It's obvious. But there are certain situations, like for example this case here, where we have lines going in different direction. Now imagine if we erase those arrowheads. Now, in this case here, we know obviously it starts, you gotta come down this way and you reach this diamond here, but maybe we might not know, because we don't have the arrowhead, if, say for instance, when we reach this point here, if we can go back up this way, because there is no indication with an arrowhead. So that is why, even though you can draw without the arrowhead, like an example like this here, you can, the best practice is to always use the arrowhead. That's the best practice. Always use the arrowhead, so that when anyone, not only you, when anyone is looking at your flow chart, they can be able to clearly know what is the flow of data, where it is headed. We can clearly tell that is where it is headed. So that's the best practice when it comes to drawing your flow lines. Always use the arrowheads. Now, the third rule. The main symbols used in a flowchart are the decision symbol, which is also called selection. So notice we have another name here. So decision, selection, condition, question. They are all referring to the same thing. Decision, selection, condition, question. They are all referring to the same thing. And the next main symbol is the process symbol. The process symbol, also called the sequence symbol. Those are the main symbols that you use in your flowcharts. Why are they considered the main symbols? Well, let's have a look at a IPO chart. Remember the IPO chart, you have 3 headings in a table. You have input, you have processing, and you have output. Now imagine if you take away the processing, which is basically your calculation. Then you input your number 1, 2, and 3, but when you go for output, remember we take away the process. If you go to output, you can't output anything. You might output what you input. That's the only thing you can do. So basically, nothing changes unless you have processing, unless you have calculation. Only then can you have something happening in your program. Similarly, that's basically why they're saying that the decision and the process symbol are the main symbol, because those two are the main symbols that are carrying out your calculation. Notice here the process symbol. This symbol here has our calculation inside of it. Notice add number 1, 2, and 3. Notice here once again, calculate average temperature. And even the decision symbol, this is what allows us to perform another form of calculation called logic calculation, where we can test if something is greater than, less than, equal to, whatever the case may be, and take different paths in our flow chart. So those are the main symbols that we should have in our flow chart, because that is what is going to give us results. And the last step, the last rule, the flow of sequence is generally top. So the flow of sequence is generally top of the page to the bottom of the page. So basically, when you're drawing your flow chart, we go top to bottom. However, this can vary. Sometimes there are loops which need to flow back to a process or decision. So notice in all the examples, we're going top to bottom. All of them, we're going top to bottom. But there are certain situations where you can go up, basically. So I think we have, look at an example of that here. So notice we are going top to bottom. We start off here at the top, we're going down. But notice when we reach output number, we can actually go back up. So that's the only exception here of going back up, when there is a need to repeat a certain part of our flow chart. But the general rule is to go top to bottom. So those are our 4 rules when it comes to developing a flow chart. Once again, you must have a start and stop symbol. You must use arrowheads on your flow lines. You must include decision and process symbols, and you should write top to bottom so that we can clearly follow the flow. Are you guys clear so far?
Yes, sir.
Any questions from anyone? Alright, so let's continue if no questions. There are also some important rules for the symbols. These rules also generally apply to algorithms and pseudocode. So some more rules we have to look at. The first rule here, processes have only one entry point and one exit point. So a process symbol, only one entry and one exit. So I think that was mentioned here. The decision, it says here that it has one line in, more than one line out. That's what they're talking about there. So decision, one entry point, but we're going to come to that just now. So let's first look at the process. The first rule. The process has one entry point and one exit point. That basically means one line in, one line out. So notice for this process here, notice we have one flow line going in, one line coming out. We would never have another line coming out and going to another symbol when it comes to a process, because a process is not a decision. It's not answering true or false so that you can go in different directions. It's only giving you one output. So there's nothing to test whether I should go left or right or whatever. So whenever you see a process symbol, it should only have one entry point and one exit point. There should not be a second or third or fourth. There will always be one in, one out. The second rule, lines with arrowheads indicate the flow of sequence. Well, we already know that. The arrowheads indicate the flow of sequence. Rule number 3, decisions have only one entry point and it's going to have one true exit point and one false exit point. So that's basically 2 exit points. You should also know that when to use the if then and the if then else structure. So let's look at that example. So notice here we have one entry point, so we can say one input and 2 output here, 2 exit points. So one data is going in, one value is going in, and 2 values can come out. Either a true value or a false value can come out of this decision. Now, what do you guys think? Can it have a third? Do you think it can have a third? Yes or no? Or maybe?
No.
No, we cannot have a third. Because remember, when you're answering a question, it's either true or false, right? There is nothing else that can be there. There is nothing as maybe. We don't consider maybe, or we don't consider I don't know. Those aren't logical answers when it comes to programming. So it's always going to be either true or false. So that means it's always going to be 2 outputs, no matter which decision we are carrying out. Now, the only way that it can have multiple outputs, let me see if I find an example. The only way you can have multiple outputs is if you connect multiple decisions together. Like for example, this case here. This is the only way you can have multiple outputs or a variety of paths. So if you notice, this is one path here, this is a second path, this is a third path, this is a fourth path here. So 4 paths we can actually take here. So, well, technically it's 3 because this flows into there. So 1, 2, 3. Technically it's 3. So 3 different paths we can actually take here, because we are joining 2 ifs together. And if you guys can remember, we did that in spreadsheet and we did that in pseudocode also. This is our nested if. So this is how we nest if together. So we question, is mark greater than 80? And if it is not, we can go to another test. Is it greater than 70 now? If it's not greater than 80, is it greater than 70? And then we take different paths here once again. So, but notice, each one of them, each one has 1 entry point, 1 input, and 2 exit points. So notice this one here has 1 entry, 2 exit. This one here has 1 entry, 1 input, and 2 exit once again, 2 output once again. So no matter how much you join together, it's always going to be 1 input, 2 outputs. Our fourth rule, the repeat loop has a process before the decision. That is, a repeat loop will always execute the process at least once. Now, I'm hoping that this sounds familiar. Does it sound familiar to you? Have you heard this anywhere? If it doesn't sound familiar, it means that you do not know the 4 differences between the loops that we would have covered, because that is actually the difference. When we were covering this chapter here, we looked at 4 the key differences between the while loop and the repeat loop, and it's very important for you to remember those differences. So despite if we're using the repeat loop in Flowchart or we're using the repeat loop in the pseudocode, the differences are the same. So this is the difference here. One difference is that the process is before the decision. Notice here, repeat, process, process is before the decision. So that's one key difference there. Statements are also process, condition is also decision. So that was one key difference we learned, that a process is before a decision when it comes to the repeat loop. And that means that the repeat loop will always execute at least once. That is the second key difference there that we would have discussed. Now for the while loop, our fifth rule, the while loop is generally the reverse. So if the process is before the decision, that means the decision comes first, followed by the process. So the decision before the process. So if you look here, for the while loop, the decision is before the process. And what does that mean? The while loop is usually drawn so that it loops while the condition is true. So this is the other difference here actually that we would have considered. So they actually summarize the differences here. The while loop loops while the condition is true, whereas the repeat loop loops until the condition becomes true. Those differences are very important to remember. So basically here, the while loop, while loops when it is true, and repeat loops when it is false. This is just a statement of the obvious. It loops until the condition is true, meaning that if it's true, you exit. So the repeat, it loops when it is false. If this is confusing you, please watch back that class. We were in detail on all of this here with further explanation. So these are the 5 rules when it comes to developing a flowchart. A process has one entry point, one exit. Flow lines must have arrowheads. A decision always has one entry a decision always has one entry and 2 exits. A repeat loop has the process before the decision, while the while loop has the decision before the process. Basically the opposite. Alright, are you guys clear on all those rules?
Sure. So for the repeat loop, the statement is false to enter the loop, and then the condition must be true to exit.
Right.
And then the while loop, the condition needs to be true to enter, and the statement must be false to exit.
Right. Exactly.
Okay.
So basically, whatever is the case for the while, it is the opposite for the repeat. Any other questions? Alright, if no questions, let's move on to the next paragraph. Alright, so the next paragraph. It is important that you practice drawing flowcharts since they illustrate the orderly flow of data in an algorithm. If a flowchart is not created properly, it can cause confusion and result in statements that are not logical or produce incorrect information. You should first try practicing drawing the symbols and then draw some of the sample flowcharts presented in the examples so that you can compare and improve as you continue to practice. The following flowcharts represent some of the examples that were written using pseudocode in the previous sections. So they basically took the pseudocode that we already went through and they created examples of those flowcharts. So we would have learned about sequential statements when it came to pseudocode, and sequential statement basically meant that we're going in a sequence, we're going in order, basically one after the other from the starting to the ending. Sequence statements, your flowcharts basically does the same. So similar to pseudocode, where a set of statements are executed one after the other from the first statement to the last. Flowcharts also depict the sequence of statements using symbols. As shown in figure 9.2, so that's going to be this one over here. So as shown in that figure, a flowchart has a start and stop symbol. We already know what that indicates. There are also small circles called connector symbols, which indicate that the flowchart is part of a larger one. So remember, the connector is not start and stop. So this here is not start and stop once again. It's an indication that you can actually connect it to a larger pseudocode. Flowchart. Sequential statements are joined by directional arrows. So that's your flow lines. Each symbol has an arrow pointing to it and another arrow pointing away from it to another symbol. That's what's indicating our direction. The symbol also contains text that explains the processing to be carried out. So we already covered that even though we know that this is the input and output symbol, we still put that keyword. We're still saying what is happening inside of that symbol. So consider a flowchart created at example 5, which finds the sum of 3 numbers. The IPO chart and pseudocode are given here for comparison. So let's look at our first example of a flowchart, which we basically already went through. First, we're going to start with the IPO chart. So IPO chart input, this here is basically indicating you are putting 3 values into 3 variables called number 1, number 2, and number 3. Under the processing, remember processing is basically calculation. You are adding the 3 numbers together. And in your output, you are outputting the result of the addition. So this here is the pseudocode. If you guys can remember, that's our title. This is our first step. We put 3 numbers into the 3 variable. The second step, we add the 3 numbers together. The third step, we output the result of the addition, and then we end our pseudocode. All that we covered in the previous chapter. So our flowchart now, at the top we have our terminal symbol or our terminator symbol, and that's indicating start, indicating where we started from. Our first main symbol after starting our flowchart is our parallelogram or input output symbol, which indicates we are putting data in or taking data out. In this case here, because we have the keyword input, we are putting 3 values into the 3 variable number 1, 2, and 3. At the second main symbol here, this is our process symbol. So here we are carrying out a calculation. We are adding the 3 variables together. Our third main symbol, we are once again at the input output symbol, and we have the keyword indicating we are outputting the result of the addition. Then finally, we are at the terminal symbol here, where we are indicating we are stopping our flowchart. You guys clear on all of that so far?
Yes, sir.
Anyone with any questions? No questions. Let's move on. So the flowchart shows a sequence of symbols from the start symbol to the input symbol, process symbol, output symbol, and then the stop symbol. The text within each symbol is similar to that of the IPO chart and is an example of pseudocode. So if you notice, it's actually like if we're writing pseudocode, just that we're putting everything inside of a symbol. And eventually you might realize that it's a bit more easier than writing a pseudocode, because you're simply writing shapes and indicating what is happening in that shape. Now, example 6 in the previous section finds the average of two temperatures. The flowchart is shown below. Notice that the text in the process symbol does not specify the precise calculation. Once again, the text in the process symbol does not need to specify the precise calculation. So this is a benefit here of writing flowcharts, of creating flowchart. If you notice here, we only have calculate average temperature. We do not have the complete formula. So say, for instance, if it was pseudocode, it would have been like this here. This is how it would have been in pseudocode. We would have had to put the complete formula, max temperature plus min temperature divided by 2, and then store into average temperature. But as you can see here, it's not necessary, as they mentioned, to put that calculation inside of this process symbol here. Because what tends to happen also is that because you're using symbols, it tends to take up more space on a page. As if you notice, this here is taking up so much space, and this here is only taking up 4 lines here, and you're finished with this. Whereas this is taking up almost 3 times that size, so, or 4 times. So if you were to write that entire formula into this one symbol here, it can actually take up a lot of space when it comes to creating flowchart. So that could be a possibility as why they allow you to summarize what is basically happening. So the paragraph continues that a description of what processing is carried out, or a series of symbols that detail each calculation, are both acceptable. So you have 3 options basically. You can either summarize what is going to happen, like we see in here, summarize that you calculated average temperature, or you can write a description of what calculation needs to be carried out, or basically type out the full calculation, like for example like this here, type it out completely. You can do that, or you can do a series of symbols that detail each calculation. Like for instance, if we take this example here, let me find an open area, we could do one symbol like this here, one process symbol. We do max temp plus min temp, and then we do a flow line, and we come down here and we say that result divided by 2, and then we come down and then we output that. So we can break up the calculation like that if you want also. Anyone can work. You either put all the calculation into one symbol, you summarize it like this here, or you break it up into separate calculations. Either one can work. Good, so let's go through this example here. In this example, we once again have a terminator symbol, a terminal symbol. We have a start here. Here we have our input-output symbol. We are inputting max temp, min temperature. Here we have our process symbol. We are calculating average temperature. And then here once again we have input-output symbol, and we are outputting the average temperature. And then we end our pseudocode, our flowchart with that stop symbol there. Are you guys following so far?
Yes, sir.
Yes, sir.
Anyone with any questions? Alright, if no questions, let's move on to the conditional statements now. So, the conditional statements, just like as I mentioned, just like what you would have done in spreadsheet when you were doing your if function, and the same thing you would have learned in your pseudocode when you were learning about if then else, is the same thing that we're going to be doing here. Now, conditional statements or flowcharts are the same if then and if then else structures, statements. Now, the if then structure, the flowchart for the if then structure is shown in figure 9.4. So, this here is the general structure. Notice they have a connector here, so this is a connector. We come down here for our condition, or basically our question, and then this is true. If the question is true, we come down this way, because notice it says T statement. T statements refer to true statement. So here is going to be false. So remember, one side is always true, the other side is always false. So this is the general structure here. So note that the condition symbol usually contains a question where the answer is one of only two options, either yes or no or true or false. The conditional statement can selectively skip or include statements based on the outcome of the condition. So it can either skip a statement or include a statement. What do you mean by that? It basically means that you can take different paths in your flowchart. So as with this example here, notice that if your answer is yes, then that means you will execute this statement here, you are executing this statement here, and then you end. But if your answer is no, that means you are coming down this way, so that means you ignore that statement, you ignore this statement here, and you stop the flowchart. So the decision symbol, it allows us to selectively skip certain statements or include those statements in our action. Or basically, we can say take different paths in our flowchart. Now, figure 9.5 shows the flowchart based on example 8b. The algorithm accepts a birth year, calculates the age based on the current year, and then displays a comment if the student is a teenager. This flowchart contains process, input and output, and decision symbols. So let's look at this example here. So we have a terminator symbol indicating start. We have a process symbol indicating that the variable this year is equal to 2019. Can anybody tell me what is the name of the function that is happening here? There's a certain action that is being carried out here.
Sir, is it the declaration of the variable?
Close, but not the declaration. Declaration is when you give a variable a data type. So if I had said this year equal integer, that would have been declaration. So what am I doing here if it's not declaration? Initialization. Very good. So here we are initializing a variable. I remember initializing basically means to give a variable a value. We cover all of this already. When we were looking at pseudocode. Declaring basically means to make known the variable by stating the name of the variable and the data type. Initializing means to give a variable a starting value. So if you notice what's happening here, we're given a variable this year a starting value of 2019. So that there is a process. The next symbol is our input-output symbol, and here we are inputting a value into the variable called birth year. So say for example we're going to input 2010. Now we come down, we have another process. Notice this is a rectangle process here. So we have some sort of calculation. Now please remember how you see I am going through the flowchart. Please try to do the same if you are ever going through a flowchart, because during the exam it's important for you to do the same thing so that you can clearly follow what's happening at each step. Because CXC can ask you a question, what is happening at a certain symbol, or even in a pseudocode they can ask you what is happening at line number 3. So the same method you see I am doing when I mark down what is happening at each variable, you should do the same thing. So this year 2019 subtracted by birth year, which is 2010, that's going to give me 9. So the value 9 is going to be stored in the variable age. If you notice, the formula is just like how we created it in pseudocode. Calculation on the right hand, and you store it on the left hand. So we come down now, since we already carried out this step here, and we're at our decision symbol. Remember, our diamond is our decision symbol. So we have to ask it in a question format. Is age less than 13? What is age? Age has a value of 9 inside of it. So is 9 less than 13? The answer is yes. Now yes is our true statement, right? So 9 is less than 13, that is true. So we go with yes. So we follow the line, we come in the bottom here, and we go down. Remember, this line is not pointing upward. We can't go up. The line is pointing downwards. We have to stop here at our terminal. Now, if that age was, for instance, 14, we ask the same question. Is 14 less than 13? The answer is no. We could also ask it the other way. Is 14 less than 13? That is false. 14 is not less than 13. So that means we have to come down. We run into another input-output symbol, the parallelogram, and we have to output student is a teenager. And then we come down here once again and we end our flowchart. You guys clear on that there?
Yes, sir.
Anyone with any questions on it? Alright. We're gonna go through one more example and then wrap up.
Sir, so if you don't initialize your variable,
Very good question.
what would be the output?
I'm glad you brought that up. So this would be an example here. So in this case here, they could have said, in this case here, they could have said mark equal 60. So that's initializing, right? So they could have said that here. So we have our terminal here. We start. We have our, so just imagine this is a process. And we initialize mark equals 0. So when we reach here now, we are going to run a test. Is mark greater than equal to 80? So is 60 greater than equal to 80? Yes or no? The answer is going to be no. So we come out here. So we follow the line. 60 is not greater than 80. We come down and we end there. Now, so that there is initializing. Now, that means every time you start up the program, it's going to keep that same 60 all the time. It's going to be the same answer over and over. 60 here once again. No, come down. Every time you run the program. So that is actually one reason why you do not initialize everything. Some variables, what you want to do is to make them accept an input. So you tell the person to put a value into the variable. So that is why in this example here, the second symbol is to input a value into the variable called mark. So in this case here, I could now enter 90 into that variable. So now when I go through to the decision symbol, I could ask the question, is 90 greater than equal to 80? The answer is going to be yes. So it's now going to output excellent results, and it's also going to output please see your teacher, and then it's going to end here with the terminal. So instead of initializing, we can accept the value into that variable. Did that answer your question?
Yes, sir.
Alright.
Sir, but if you just put like a processing there, right? But you didn't put a value for the variable that it should start at. What would the flowchart or the code still run, or would it not?
Well, remember this is not a program. So this here is not a program. So it won't technically matter much. It might the most it would do is confuse a person. Because if you're gonna write the program, it's gonna be more simple, because in the program you can clearly see that the variable, what you're gonna do with it. If you're gonna input a value, or if you're gonna say it's equal to 90. So even if you put rectangle mark, if that's the question you were asking, and you put nothing else, the most that's going to happen is that it's going to confuse the person, whoever's looking at the flowchart, and they might wonder what's happening here, because actually nothing's going to happen here, because mark has nothing inside of it, because we didn't give it a value and we didn't input anything. So this would just be an incorrect design when it comes to creating a flowchart.
Okay, sir.
Alright, so let me just go through this paragraph and then we're going to wrap up. So A process symbol is used to initialize the variable this here. Now, the if-then decision symbol in figure 9.6, the one we just covered, shows that two statements are output if the condition is true. So, two statements here. So notice, remember, yes is true. Two statements, excellent result, please see your teacher. These are the two. So, two statements are output if the condition is true. Otherwise, they are skipped to join the directional arrow below the last output statement. The figure also shows two consecutive outputs. So, remember, consecutive means one after the other. So you have one output here, another output right after. But depending on the algorithm, both output statements can be placed in one symbol. So in this example here, it didn't make much sense to separate the two outputs because there's nothing in between here. So, for example, if that was too large. If this line here was to go from there to here, then it would have mattered that we separated the two, because based on the flow, what's going to happen, if it is yes, we output excellent results, and then we come down to please see your teacher. But based on the new line, if it is no, that means we follow the line, we come here, we ignore this one here, and we carry out this one. We carry out the second output. But in this case here, that was not the case. The line went straight to the end. The line went straight to the end here. So basically, these two here can be grouped together as one single output. So notice that the yes and no placed near to the decision symbol are in different locations when compared to the flowchart. So look at this one here and this one over here. Notice it does not matter where you place the true and the false. Notice this one has the no here, this one has the yes here. So the yes on the right, no at the bottom. Notice this one here, yes at the bottom, no on the right hand. It does not matter where you place the true or the false. It depends on what you want to run, which direction you want to go. So for instance, you could have put yes here, that you wanted when it turns yes to end the program, and when it turns no to run this here. It all depends on what you want. You would place the yes or no in which direction, and you would connect it to what lines. So these labels must match the logic of the algorithm and can therefore be used at the appropriate point of the symbol. So it all depends on what you want, basically. So to wrap up what we covered today, we looked at 6 symbols that you must remember what the symbols look like. You must remember how to draw them. An oval is a terminator, parallelogram is input-output, rectangle is process, diamond is decision, circle is connector, and a line with the arrowhead is called a flow line. We looked at various rules that you need to remember. We once again looked at what is a sequential statement, what is a subpart of a flow chart, how to create that, and then we looked at how to trace a flow chart, We started conditional statements. We looked at the if then. The next class, we are going to start with the if then else. Any questions before we close off?
No, sir.
Alright. If no questions from anyone, that will be it for today's class. Enjoy the rest of your night.
Good night, sir.